Hi everybody, I'm sorry I couldn't be there to teach you myself today, but unfortunately I have a doctor's appointment at the neurologist today. So today we're going to be looking at base E and natural logs. Again, this should be done without a graphing calculator. So first thing I'd like you to do is to try these 4 warm-up problems. Now, my suggestion is that you hit the pause button, and then I'm going to work through them with you right now so you can see what the answers come out to be. But I want you to give them a try. So hit the pause, see if you can do them. Now's when you should hit the pause. Okay, so I'm assuming that you paused, and we're now going to work through this first problem together. If you got your answers right or you just kind of want to speed ahead a little bit, that's perfectly fine. Okay, so there's that first problem. Let me scoot it up a little bit so this is the whole screen. As you can see, I cannot get these two bases to be the same. Had it been a 64, yes, but since it's a 63, no. So I'm going to log both sides. Again, the reason for this is so that I'll be able to use the power property of logs to get the variable out of the exponent. So now that I've logged both sides, I'm going to take my exponent, I'm going to move it out front. All right, now yesterday a couple of y'all asked me, could I just divide by log of 8 on both sides? Absolutely at this point. I am just trying to be as consistent as possible, but I'm certainly willing to give it a try, so let's do that. So we're going to divide by log of 8 and divide by log of 8. Now the reason this is going to prove helpful is because we only have a variable on one side. Now, if you want to go ahead and put this in your calculator, you can. I'm just kind of waiting till the last possible minute because I'm going to have the calculator do most of the work for me. Add the 4. So this is what you're going to see me put into my calculator. So that's what's going in the calculator. So now let me come over here. Let me grab my calculator, put it where you can see it. Okay. So if you have the smaller calculator, which is what you should be using for this, use that N over D button to make it into a fraction. I don't have that option. So I'm going to have log of 63 divided by log of 8 plus 4. Okay, so my answer, remember, go out 3 to 4 decimal places out of respect for the old textbooks that I had to learn my math with. 5.99, and the third decimal place would be a 2. If you want to go to the fourth decimal place, it's a 4. All right, so that's that first problem. And again, if now is when you'd like to pause, this would be a great time. I'm just going to come over here and work B. Okay, so there's my B problem all ready to go. If you need to pause it so you can try and work it, now's the time to do that. Okay, so I'm assuming you paused it so you can work it out. So at this point, I cannot make a 7 and a 52 be equal because 52 is not some power of 7. Had it been 49, yes. So I've got to log both sides with the sole purpose of being able to move my exponent out front. Okay, so I'm going to have 2n log of 7 equals 4n plus 1 times log of 52. Now, unlike the last problem, I have variables on both sides, so it really will not help me to divide both sides by a log of anything at this point. If I only have a variable on one side, cool. If not, I'm going to have to do the distributive property and rearrange my terms and factor. It really just doesn't work any other way. Okay, so I'm distributing Okay, so at this point, you should see that the two terms that I'm underlining in orange both have an N in them. So I need that to go to the left-hand side, or if you really want, you can put it on the right-hand side. But I just like to keep my variables on the left. It's just kind of a personal style thing. So I'm going to subtract that to the other side. Okay, so at this point, all my variables on the left, I'm going to factor out the variable. So just the variable and the variable alone, I'm leaving everything else in place. And now I'm going to divide both sides by what's inside that parentheses. So here's what goes into your calculator. And I will show you that in just a moment. Okay, so that's what I have to put in. Let me grab my calculator so you can see it. Now, again, I don't have that N over D nice fraction thing, so I've just kind of got to do my numerator and denominator. So parenthesis around my numerator, log 52, close parenthesis, close parenthesis. So that's my numerator, divided by my denominator. 2 log 7 minus 4 log 52. Okay, and there is my decimal answer, 0.3317, and it's supposed to be negative for my eagle eyes out there who noticed that. All right, so any questions hopefully about that have been simplified. Let's try C. All right, so let me pull over here so you can see C. I'm just going to rewrite it a little bigger. Okay, so this is a little different. We haven't seen something like this before. I can't work with a problem with a square root on it. So I am going to square both sides. Okay, so on the left, I have 16 to the 2 of x power. And on the right side, I've got 4x plus 3. Now take a look at those bases. You should notice that you can rewrite 16 as 4 to some power. And we've got a little 2x there. All right, because the bases match, you can effectively cancel them out. So on the left, I'm going to have 4x. On the right, I'm going to have x plus 3. Move your x over to this side. So 3x equals 3 and x equals 1. And there's my answer all done on that one. Okay, and let's slide over to D. Again, I'm assuming that you're going to pause if you need to. Okay, so I can rewrite this if I do a cube on both sides, well, on this side. Notice when I do this, I'm always making my denominator, now I'm not going to say it's smaller because 1/8 is smaller, but the denominator is 2 versus 8. So I cannot cube this side to turn it to that. I can't do that. I always have to lean toward the, not the smaller denominator, but the smaller integer value. All right, so this means that x will be greater than or equal to 12 plus 3x. Okay, let's do a little solving. I'm just going to move this x over here to the left side. And then I'm going to divide by -2. Okay, so let's talk about my answer. So my answer says x is less than -6. So a few of you missed this problem or a problem similar to this on the quiz because you didn't have your inequality going the right way. So we need to test it because depending on which way you kind of solved it, because there's a couple of different approaches, you could have moved the x over there and the 12 over there, you might or might not have the right answer. So I'm going to test my inequality. So test your inequality kind of over here on the side. All right, so our answer supposedly is any value that's less than or equal to -6. So I'm just going to let x be equal to -7 because that's less than -6. Now I'm going to put this back in my original problem and use my calculator to help me. So I have 1/2 to the -7 power is supposed to be greater than or equal to 1/8 to the 4 plus -7 power. So that's supposed to be 1/2 to the -7 is supposed to, -7, supposed to be greater than or equal to 1/8 to the -3rd power. Okay, so that means, this is 2 to the 7th is supposed to be greater than or equal to 8 to the 3rd. All right, so maybe you don't know what that is. So this is where you call in your non-graphing calculator. You say 2 to the 7th. All right, that's 128. Okay, 8 to the 3rd. That's 512. That's not true. That's a false statement. So the thing that we kind of talked about in class is if your base is less than 1, you're supposed to flip your x or flip your inequality. So I actually need to have this as my answer. So now if I use values that are bigger than -6, which would be like -5, 0, 1, and 2, I'll get a true statement. So that's how you can test that really easy. So there's our warm up, all kind of worked through. Maybe you needed that, maybe you didn't. So today we're doing natural log. Now, everybody on your calculator, non-graphing or graphing, you should have, if you look somewhere on there, an LN, and usually right near it is your E button. Some of you eagle eyes may have spotted over here, there's also an E button. So the E is just the Euler number. So when you see this word right here that looks like Euler, it's actually pronounced Euler. It's a Swiss mathematician. He actually was on the Swiss franc before they went over to doing the euro. Okay, so Swiss mathematician, there's your tidbit for today. Okay, so let's take a look at some of these things. So using your calculator, let's kind of like think through some of this stuff. Now, first of all, anything to the first power is just itself. Now, let's talk about what E actually represents. So if I go to my calculator and I go down here and I do second and I get my E to show up, there it is, to the first power. That's what it is. It's 2.718. So it's a number like pi. It's irrational. It's my personal favorite irrational number. It's 2.718 is usually what people round it off to. Notice 3 decimal places. So let's go over, let's fill this stuff in. So y equals e to the x. That is the Euler number. So let's kind of like put that in there. To the x power. Down here, if I do 1 over e, that's just the inverse. Sorry, the reciprocal. Sorry, I chose the wrong one. It can also be written as e to the negative x power. You can do that as well. We also have a little bit of notation down here. Ln, that is log base e of x. Now, this stuff with e and natural log, they get used a lot. Those of you who are thinking about careers in biology, you will see that sort of show up all the time. Okay, sliding over here to your little box. So log properties revisited, but for natural logs. So this is the same thing as saying log base e of e And if you remember, whenever you have the base and the argument the same, that's just equal to 1. Over here, if I'm doing this one, this is log base e of 1. And when you have to do something like that, again, if you're not 100% sure, you can do log of e. There's my parentheses. As you can see, that is just going to be equal to 1. Oops, sorry. Did the wrong. I did the previous problem. I got to do this one. So ln of 1. That's just going to be my 0. Because that's the same thing as writing log base e of e to the 0 power. So that's just 0 for my exponent. All right, now you can use your product rule on this. So you can say that this is ln of x plus ln of y. Here's your quotient rule. You got ln of x minus ln of y. And then finally over here, this is your power rule. I can't exactly read what that exponent is. It's so tiny. So I'm just going to say that's an n. So that'd be n times ln of x. Okay, so let's apply this new base e stuff. And again, if you need to, you can always switch over to log base e. All right, write this in exponential form and find the values. Okay, so I'm going to write it as log base e. So that's the same thing right now. I have not written it in the other form. So I'm going to start with a base, go over here to what it equals, and then back to the 13. So this is the same thing as e to the y power equals 13. This is log form or natural log form, and that's exponential form. Okay, let's come over here and let's try another one. So on a problem like this, I have a choice. I can divide the 8 to the other side, or I can move the 8 back up to be the exponent. I'm going to move my 8 back up here to be the exponent. So this will be log base e of x to the 8th power equals 2.14. So just like I did before, I'm going to start down here with my log base, swoop under the equal sign and over. So this will be e to the 2.14 equals x to the 8th. Okay, so same problem. We're just kind of rewriting it. All right, now we have to condense into a single log. So just like we did yesterday, if you have a multiplier out front, you got to turn it back to an exponent first before you combine your logs. And then you're going to use your quotient rule. So this is the same thing as natural log of 10 over 3 divided by 8. Now, if you'd like to go ahead and simplify that unattractive fraction, you can, but you could also just leave it looking like that. Because remember, your goal with this is not to solve it, it's to write it as a single log. So just to condense, that's condensed. All right, let's try another condense. I see a multiplier, that's got to go up to be an exponent. Okay, before I put everything together, remember, check to make sure which natural logs are positive. As you can see, they all three are, so it'll be ln of 40 times 1/2 squared times x. All right, so I need to put this stuff together right here. This is a great place to use a calculator if you'd like. But either way, though, you're going to end up with ln of, remember that was 1/4 times 40 of 10x. And you're all done with that. All right, our last two problems for today's notes are going to be these two equations. Let me grab a sheet of paper so I can write a little bigger because there's really not enough room down there. Okay, so I need to get the e to the 4x by itself. So we're going to do backwards order of operations. I'm going to move the 2 first. That -2 gets added to the other side, and then I'm going to divide by 3. Okay, so to solve this kind of exponential, if you can get both sides to be base e, fantastic. But I don't even know how to start getting 17/3 to be 2.8, so on and so on. I don't know how to do that. So instead of taking the log of both sides, we're going to take the natural log of both sides. Okay, so the reason we do this is so we can move that out front. Okay, up above in the box, we defined what ln of e was, because these are opposite operations, so they're just equal to 1. So that's 4x times 1. Now, if you don't want to write times 1, you don't have to. I'm going to get rid of it here in just a moment. But since this is your first time seeing it, of course I wanted to do that. And then I just have to divide both sides by 4 with my calculator. So let me put down what I'm about to put in the calculator. So that's what's going on my calculator. Let me pull my calculator over. All right, so here, I'm going to have ln of 17 divided by 3, close your parentheses, divided by 4. Yeah, that's it. That's all you have to do. And then you got your decimal answer, which remember, you're still going to be doing your decimals. And there you go. There is your answer for that problem. Notice I'm using 4 decimal places. If you want to use 3, though, that's fine too. All right, let's go to our final example for today. Scoot it back down so I got a little place to write. So this is k. That's ln of 2x minus 3 is greater than 6. All right, so I always have a hard time kind of thinking about this, so I'm going to put the base on the log there. And I am going to rewrite it. So e to the 6th power, and then I've got my argument over there. So e to the 6th power is less than 2x minus 3. Now, I know a couple of you are just like, how do you know which way to turn it? If you turn it the wrong way, it's going to be okay because we're going to test it at the end, all right? So even if you accidentally got your inequality going the wrong way, do not worry. It's all going to work out. So I'm going to move the 3 to the other side by adding it. And then I'm going to divide by 2. All right, so I think that's what my answer is. I need to turn that to a decimal. Time for some calculator help. So first thing I'm going to do is I'm going to have my numerator. So I need to put parentheses around it. So there's my e to the 6th power plus 3. And I'm going to close that parenthesis divided by 2. All right, so I have 203.214 4 is less than x, or x is greater than 203.2144. Okay, so I think that's what my answer is, but I'm going to test it to make sure my inequality is going the right way. So here's how I'm going to do that. I'm going to say test. I'm going to pick a number that's bigger than 203.21. You could pick 5 million if you want. I'm just going to pick 204. Okay, so I'm going to go pull the problem from up at the top. So I've got ln of 2 times 204 minus 3 is greater than 6. So I need to see if that's true. So let's go to our calculator and let's test it. So that's ln of, I guess I didn't need that extra parentheses, 2 times 204 minus 3. All right, so that is 6.004. And that is true, which means I have my inequality going the correct direction. Yeah, so that's a quick way to fix that If you're always confused about which way should my inequality go, give it a test. That way you'll know for sure. So pick something that you think is going to be true, see if it actually is. All right, so those are your notes. Now, if you look down at the bottom of your paper right here, it says your homework is on page 505. It is, if you flip it over, that would be all of these problems that are on the back side. Please do the odd problems only. So, like right up here, it says write an equivalent exponential or log function. So this one you need to turn to a log. This one you need to turn to an exponential. If you slide on down, this says write as a single log. So it's condensing. Then you've got just a few solving problems. You got 2 of those to do. You got 1 inequality to do. Then this one is write as a sum or difference. That means to expand. And then finally, solve this using natural logs. Natural logs and logs kind of work the same way, but one's base e and the other one's base 10. So try taking the natural log of both sides of the equation. Now, when you get down to the bottom, these are both even, so there's not an example. So let's just agree that we're all going to do 52, okay? As far as the one that's above it, there's an odd problem in each category for you to do. If you look online, you should be able to find the entire key. So if you find you struggle with one of these problems, try a different one. Okay, so that's the notes for today. I'll be back tomorrow to answer all of your questions. Again, I'm sorry I had to be out today.